Up next, we have Oliver Schneider. He is an assistant professor, human-computer interaction researcher, and haptician at the University of Waterloo. Haptic technology engages the sense of touch for a user, providing physical feedback in computing. Oliver and his lab are currently working on developing a set of computing tools for the creation, deployment, and study of haptic technology. Off to you, Oliver.
Hello, everyone. My name is Oliver Schneider. I won't introduce myself because I've already received a fantastic introduction there. I'm here to talk about haptics. I call my research field haptic computing, and it lies in the intersection between human-computer interaction and haptics. Now, haptic technology, I'd ask who here has heard about haptic technology, but I only see about 5 faces. Haptic technology is anything that involves the sense of touch. So it could be something like vibrations in a phone, or it could be something like force feedback, like this paddle that you push on and you receive a force pushing back. And right now, haptic technology is moving from research labs to industry. So it's this really interesting space where you see it at all of these different startups. So, there are over 24 companies that are focused on haptic design that really invested in it. 14 of them have started in the last 5 years. So really see an investment in this technology. We really see the possibility that this technology could affect our day-to-day lives. The problem that people are facing is that hapticians, makers of haptics, are now victims of their own success. Working with one haptic device is hard enough, but now we have dozens of products and hundreds of prototypes. This is just the beginning of the menagerie of haptic technologies. A lot of these are from recent research papers. Some of them are products, and I could just go on. In fact, there was a recent project called Haptipedia, just trying to sort all the devices. And it wasn't even touching about half of these because it only focused on subclasses of force feedback devices. So haptics is this really challenging design problem. And my long-term goal is to develop a suite of haptic computing tools to assist in cross-platform creation, deployment, and the study of haptic technology. The way this would work is you have a designer of some sort who wants to create some sort of sense of touch. This could be friction on a touchscreen, it could be vibration on a smartphone, or it could be a rich VR experience where you're picking up props and you're feeling temperature or any other sort of physical sensation. And the way that you might try to work with this is the same way you might try and design for a building or for some other sort of product. You might start to sketch ideas and maybe edit or refine those ideas to try and develop them to become something interesting. Eventually, you might deploy them into a target application. Along the way, you probably do best practices in design, like reusing existing ideas. So, looking at building a design gallery of what might inspire you or other ideas so you can build upon them. Or you might be able to collect feedback to see what users are, potential users are saying when they're trying to interact with your product. My goal is that in the future, I think everyone will be able to work with haptics like any other media. So the same way that you work with images, video, or sound, I'm trying to build that infrastructure to make that happen so we can just share haptics back and forth. Now, I've already started building this platform. There's a set of these different tools. I'm going to talk about a couple of them. And they fall into these different activities. So they support different activities because I'm really trying to understand the process. And to give you an idea, I'm going to show one example about tactile animation. So this was a collaboration with Disney Research back during my PhD. And the idea here is we want to be able to animate haptics on the skin. So here we're talking about vibrotactile grids. Now, when I say vibrotactile, I just mean vibrations that you feel in the skin. For example, your smartphone. When it vibrates, you feel that in mechanoreceptors in your skin. Now this grid is a lot more flexible because you can use it spatially. So you could have, a tap on the left or the right to tell you to turn on a motorcycle or in a car. But Disney was interested in using it in areas like new media. So you could feel like a snake slither up your spine in the middle of a ride. Or you could feel some sort of rain in some sort of immersive educational experience. And this is more expressive than you might think because you can look at illusions. If you take two actuators and you vibrate them at the same time and the right way, you create a phantom sensation in between them. And if you sequence these actuators in the right way, you create what's called apparent motion. So it feels like it's continuous motion across the skin. And what's cool is you can combine these. You can create these phantom sensations and then sequence them in a line. And so you can create these kind of arbitrary motion platforms across these arrays, meaning that you can use space in a continuous way. So you get something like this. I'm gesturing to my screen, where you have this motion on moving across your skin. Now the problem with this, in this algorithm, is that it needs to be pre-computed, which is really, really challenging for design because it means animators can't feel their designs. When you're sketching or you're drawing or you're creating animation, you really rapidly see what you've created, step back, kind of edit it right there. And if you had to like compile a program in between each step, it becomes really, really, really slow. So I set out to try and solve this problem. This should give you an idea of the design process that I follow in my own work, as well as giving you some of the idea of what haptic technology can do. So I started by doing sketching, which we've already talked about, to create this interface that will allow animators, visual animators, to create sensations. And then I implemented a prototype in Python. Up here, there's an animation window where you can move these different objects around to feel sensations moving across the skin. And down below, you have a set of time-varying keyframes. And so you can sequence it in time. And so you have animation. We worked on a device that looked like this. So this is a haptic pad with a set of actuators. And the key innovation here is how we get in between those actuators. How you get this purple object, this animation object. So the algorithms that I've already told you about function really, really well in 1D. If you have two actuators, it's really well known how you can create a sensation between them or how you can create motion between them. And there's some trade-offs in how you render those. It's actually been shown to also work inside your body and between your body, like outside of it. So if you have your two hands, you can feel like there's like something moving between them, which I think is super trippy. But when it comes to these spatial grids, it's really difficult to understand how they work in 2 dimensions. So we generalized this algorithm into a set of, to work in a triangle. And if it works in a triangle, it can work in a mesh. We looked at how you might be able to interpolate between them. And this is where we start to get feedback from users is we try to do these psychophysics studies to understand what people perceive. Does it get quieter in the middle or does it move really quickly? How fast does it move? We looked at 3 different rendering algorithms, and I'll spare you the details of the study, but we decided that you want to use logarithmic power because it maintains the power the most evenly across the motion in the triangle. So with that, we were able to create the animation object in the animation tool. And what you see right here is a visual animator, so someone who has no experience with haptics, moving at a vibration on this in this tool. You feel it on your back in real time. So what this animator has been tasked to do is to create a heartbeat. And what they're doing is they're dragging it up and then moving it over to the left and then moving it up so it feels where their heart is. And they wouldn't be able to do that if they couldn't feel in real time. They'd have to pre-compute it or just take a guess, and it might not feel just right. So this really closed that iteration loop so you can iterate really, really quickly, and you get feedback from yourself as you go. What I like about this approach is it also generalizes to other types of devices. You could have a wristband, so something like maybe a watch strap. And because we know about 1D interpolation, we can do these kind of animations across those. You could do it embedded in 3 space. So if you have a mesh on like a wearable, you could kind of move it across that mesh, or you can move it on multiple objects as long as you constrain these objects. This is the final tool that we built, and it was designed for a chair. So that's why you see more actuators in the left. The demo here had people designing for a video recording of the game Split Second, which is kind of like a realistic Mario Kart where there's lots of explosions and crashes. So it was really good for a seat that was like rumbling around to give you a good idea of what, like to experiment with haptics. And at the WIST conference in North Carolina, we basically created a haptics track for this 1.5 minute video in like an hour or two before the demo itself. So we felt that this tool was actually fairly robust. People could come in, enjoy the experience, and they could edit and change things, which we thought was really powerful. And so we were able to get feedback there. And in the study, we were able to get animators, visual animators that worked at Disney, their interns, to come in and play around with this. So we had 6 animators create all these different haptic designs to show that this tool could work. And that's how we created this feedback. So we're able to take people to transfer the skills from one domain into another. So that gives you an idea of some of these tools. Many of these tools are software, but some are conceptual. And I want to draw your attention down to this bottom square right now, which is some recent work that was published at the Computer-Human Interaction Conference, CHI, in 2020. Working together with Aaron Kim in my lab, we developed what's called the HX model, which is ways that you could think about haptics. One thing that's really challenging with haptics, and I'll give you a story in a second that shows this, is how do you communicate what feels good and what doesn't? When it comes to colors, we have a language that even lay people understand. You might say, oh, I want a warm color, a cool color. Or if you're a musician, you might be able to say major or minor keys. There's this kind of language that you can use to communicate to people. But with haptics, you can say things feel rough or smooth, maybe warm or cold, but you don't know anything beyond that. How do you describe different vibrations in a cell phone? How do you describe whether the slithering is just right or not? And so what we've done is we talked to both potential end users, so people who don't know anything about haptics, as well as people who are experts in haptics, to understand what makes a haptic experience. And we came up with these different dimensions. So if a designer is trying to design for a user, we have a set of usability requirements. So these are things you need to check off to make sure that it's usable. And then we have experiential dimensions. So these are pragmatic features, the usability features, things to make it effective, and then experiential things that are hedonic. They just make it feel good. And we came up with 5 different ways they could feel good. Harmony means everything just kind of fits together and feels really good, which is really essential in haptics. Autotelics means that it feels good in and of itself. So you just, it's a very pleasurable sensation. The same way you might feel silk or like a high thread count piece of bedding. It's like, oh yeah, this just feels nice. Realism and immersion are very important for virtual reality or for simulation if you're doing surgery, for example, like remote surgery. And expressivity is, does it capture different inputs and does it explain how you can different states in the system or different kinds of actions. If I kind of push and prod or play a game in a certain way, does it give you different varied impact? So that gives you an idea, I hope, of what it's like to design for haptics and some of the challenges there. But I'm also using this platform to understand how people design haptics, really getting at the process of it. And I've looked at 2 different groups of people, both experts and novices. And I'm hoping that this will kind of explain the methods that we use in haptic experience design, what are best practices and where the challenges are if you're not familiar to the design. With experts, we interviewed hapticians, so people who make haptics. And in particular, they're skilled at making haptic sensations, technology, or experiences, which reflects that there's a very diverse set of people that work with haptics. They're either psychologists, engineers, or designers or application developers. And so you have these people with different expertises that have to kind of draw upon expertises of other people. And they all practice, they follow one thing in common, which is they practice haptic experience design, which is the design of interactive technology to one or more perceived senses of touch. It's usually multisensory. There's usually something coming in for your eyes and or your ears as well, since haptics really kind of relies on that harmony of all of the different senses to make it effective. And so you have to consider all of that. Now, from these interviews, we came up with 5 themes, or 3 themes with 5 sub-themes. That's just a wall of text, so I'm not going to dive into it, but I will give you a summary to give you an idea of what the process is like and the challenges that hapticians face. So the first challenge is that haptic experiences are multisensory and vertically integrated. It doesn't end at the actuator. So the problem is that it doesn't end at the actuator. There's a lot to do with the case of the device, the mass of the device, the mechanical coupling between the device and the hand. So if you imagine a smartphone, for example, if you were to change a component inside it, it changes the mass, which changes how any vibrations in it propagate throughout the entire device. And so you really have to understand what the device is like to be able to have something that's consistent. It also could be, sitting on, I could be holding it with one hand or one hand and navigating with my thumb. I could be holding with 2 hands, pressing with my finger, or it could be in my pocket. And all of those mean that you're feeling in different parts at different ways, and you'd be pressing harder or more softly. And so there's all of this variation that you have to compensate for with haptics. So it's this really tricky design problem. Audio feedback and tactile feedback and visual feedback have to happen at a certain time. So if you don't have them synchronized, it's just going to feel off. It's going to be broken. It's not going to be harmonious. And this is really challenging because you have to synchronize the graphics pipeline with audio and with haptics. So much so that for Apple, when you design for haptics, you create audio haptic files, AHAP files. And so you actually work with audio and haptics at the same time because they need to synchronize it so carefully. And feeling right is something that's very individual. We all experience touch in different ways. Some of us are more sensitive or less sensitive. We have different preferences, and we have different prior experiences. If someone's a cat person, they might interpret something to be more like a purr, and they might like that sensation, or someone else might interpret something to be like a motorbike. And so you have to be careful how people are going to feel these different sensations. So there's tons of individual differences. If we zoom out a little bit, we can think about how people work in groups when it comes to haptic experience design. So these hapticians really see themselves as having to rally the ecosystem. They have to be kind of Renaissance people to be able to understand how to use all these different moving parts. Because it's vertically integrated, because it involves all these different senses, because it involves hardware and psychology and design, you need to be able to have the right set of people that work together to do this. You might be able to encapsulate some of this information in guideline books. So you might say, the design of a physical widget like a slider, it feels force that ramps up and then it clicks and then you're good. And then on the way out, it kind of ramps up and then it kind of clicks again. So you can encapsulate some of these different things in demonstrations or documentation. But at the end of the day, it's still at the engineering level, so it's hard to communicate about these designs. And you need to really feel it to get it, which is why it's so important that we have all these demos at haptics conferences. If we zoom out one more level, we see that design is embedded in the current technological culture. Really, our hapticians expect that it's going to be a standard feature, but in the future, right? People really don't know what to do with haptics. So right now, I mean, we're seeing vibration in cell phones, in mobile wearable devices, and we're starting to see things like props in virtual reality, but none of this has made it to, only the most basic of haptic sensations has made it to commercial products or to end users because it's so challenging to do. And it really all comes down to this little vignette. One haptician described a customer that came in with a question. They said, hey, I've got this device, I want it to feel variable. I don't know what variable means. This haptician didn't know what variable means, and this customer had no clue what variable meant. And so what the haptician and the customer had to do is they had to go around the lab, play around with all of these different demos live in person, and changing all of the different hardware and software and tuning it in all of these different ways. That's really, really challenging in order to come up with a shared understanding of what is variable and what people can do with it. And so that's where that barrier of communication is really there. And that's why we're trying to develop these models to understand how people can communicate with touch. So to kind of sum this up, haptic experiences are complex. Hapticians need to form multidisciplinary teams. And haptics is hard to understand. So you really need this infrastructure to be able to design for haptics. And it's just not there yet. So that's what my lab is trying to do. To illustrate where this kind of breaks down is when you look at novices. So this is why haptic design is relatively inaccessible to other people. We did this one study over the last couple of years where we recruited student teams to develop a learning environment for a STEM topic using one or two haptic devices. We had these two different devices. One is a haptic paddle. As you push, it gives force feedback. And the other is a pantograph, which as architecture students, you may understand what a pantograph is. Usually I have to explain it. But in this case, it's a force feedback device in 2 dimensions. As you move around, you can feel like walls and you can feel resistance on it. We collected a bunch of data. We shipped these devices out to students who are participating in an innovation challenge for a major haptics conference. And then we analyzed their data using a qualitative method, using thematic analysis, and probably informed by grounded theory methods to come up with several themes. And the big conclusion was we found novices were overwhelmed with the technology. They had to deal with all of these different things, and it was all they could do to really focus on implementing, getting it debugged, getting it running. meaning that they often skipped over or didn't iterate on things like conceptual design or communication. They managed to create these interesting systems that ran, but they couldn't explain why it was important or whether it was tackling the right problem. And they didn't have a good conceptual design at the beginning to make sure they're solving the right problem or communicating the right thing. So our big conclusion here is that while experts are deliberate about their process, they're trained in general design principles and they apply them to haptics to try and overcome these challenges. Novices need guidance through even those activities because you have to work with conceptual design, you have to work with programming for all the different senses, and you have to deal with evaluation and hardware all at the same time, and it just becomes overwhelming. So far I've talked mostly about vibrations and these force feedback devices. I also realized that I'm just over 20 minutes, so I'm going to try and conclude relatively quickly. So we've talked about vibrotactile feedback, so vibrations, and a bit about force feedback in education. I've also been working on touch-based social robots, so these robots that help people calm down or deal with stress or anxiety, and spatial displays for blind users. Do I have time to do maybe another 2 minutes on spatial displays? I see a nod. Okay, great. So I'll talk a little bit about spatial displays for blind users. So one of the application areas where I'm trying to practice haptic design. And this project is called Dual Panto. I realize I'm not gonna be able to stream the audio, but we'll give it a go. This is a project part of my postdoctoral work at the Hasso-Plattner Institute in Berlin. So here we have a video game and we have someone playing and shooting these adorable little zombie bunnies. They're zombies, it's okay if they're hit. And this would be completely unremarkable, except for the fact that the person playing this is blind. This is Edis, he's playing this game. And the device that he is using to play this game is called a Dual Panto. This is a haptic device that enables blind users to continuously interact in virtual worlds. With Dual Panto, apps can move beyond 1D scanning to spatial interaction. Right now, most displays for blind users, or people who are visually impaired or can't see the screen, typically use audio, and so the has to be streamed. Here, we're trying to do spatial information, but you don't typically with spatial information like braille displays, you have to search around with your hands. Here, we're actually pushing the information, so you can actually track moving objects. So we built this device, building hardware and software stack on top of it, and we brought it to these end users who are all blind or visually impaired. We have them play a soccer game and play against us. You don't get to hear all the cheering and things going on here. What you can hear is that if you could hear it, is you see the participants just kind of having a blast, and then us as a team, like our researchers, we got way into the study. We're just like cheering them on, like, yeah, you can do this, or we would challenge them and then they would completely beat us. And there was just like, oh no, we built this device and now we can't even play these games. So it's just a lot of fun. One of the most rewarding studies I think I've done. So we played them, we got their feedback in these exit interviews. So saying, multiplayer is really significant. I had fun crushing the other players. That was a fun learn. This is in German, so I was delighted to figure out the German word for crushing other players. And it's cool because you could play when you want, right? You don't have to wait on the device to do something. It really was immediate and continuous. And that was really cool to see that participants were able to use that to play these new kinds of games themselves, rather than kind of waiting for a screen reader or listening to audio cues like people had previously done for video games. Yeah, it really gives you the opportunity to play, pulls you in, like people say about computer games. So to wrap up, if you're someone who wants to design for the sense of touch, there are lots of different activities that you need to do. And you need lots of different support to do that. But right now, I'm hoping that in the future, everyone will be able to work with haptics like any other media. And if you're curious about haptics, I invite you to come talk to me after the talk to be able to see how we can address this problem, or how we might be able to design interesting haptics to help people. Thank you.